Do you remember the rules that we used to reduce fractions? Remember, whatever you divide the numerator by, you have to divide the denominator by the same number? Well, we can apply that same rule to ratios. Now look, you do have to watch the other video to learn what a ratio is. This is the second video on reducing them. So if you're not sure what a ratio is, go back and watch the video I made about representing ratios. Now we're going to use that same rule of reducing fractions to reduce ratios. Let's start with this example. We're going to write the ratio of squares to hearts. So we count the squares, we get 3. Any more? No, we have 3. So we'll write 3 squares. And we can write dot dot. That represents 2. And hearts, we have 3 hearts. Now, all we're interested in is the numbers. We have a 3 and a 3, and we ask ourselves, what's the greatest common factor between them? In other words, what number divides into both? 3 divides into both. So we can divide by 3. We're going to do this. We're going to divide this number by 3, and we're going to divide that number by 3. And when we do that, we're going to get 3 divided by 3 is 1 square. Dot dot. 3 divided by 3 is 1 heart. And we've effectively reduced this ratio. We have a ratio of 1 square to 1 heart. We can also write it like this. We can write 1 square with the word 2, 1 heart. Or we can write it as a fraction. We can write 1 square. I'll write S to 1 heart. I'll write an H. This is a 1. And all of these are correct. Number 2, we want the ratio of red shapes. Okay, red shapes to green shapes in lowest terms. So let's count the red shapes. We have 1, 2, 3. We have 6 red shapes. So we can write, let's write it as a fraction this time. We'll write 6 red on top of how many green? We have 1, 2, 3. We don't care about what kind of green shape. We just care that it's green. That's all it says. So we have 3 green. Now let's reduce this. We can divide by, what goes into 6 and 3? 3 goes into both, so we can divide by 3. So divide this one by 3, divide that one by 3, and you're going to get 2 red, because 6 divided by 3 is 2, and on the denominator we'll get 1 green. Now remember, these are not fractions. This is a ratio. We're comparing red things with green things. Remember fractions, what the denominator represents in a fraction? It represents the total amount of things. Well, here, do we have one total amount of things in this picture? Of course not. So this is not a fraction. This is not a total on the denominator. It's just a comparison between red and green. And we just happen to use the same symbol to represent them. Now, how about ratio of squares to triangles to hearts? Oh my God, we got 3 things. We got squares, we got triangles, and we've got hearts, and we need it in lowest terms. So let's count the squares. We have 3 squares. So we can write 3 squares. 3 squares. And let's use the word 2 this time. 2 triangles. Okay, we have a lot of triangles. 1, 2, 3, 4, 5, 6 triangles. So we'll write 6 triangles. And I think we had 3 hearts. Yes, we do. 3 hearts. To 3 hearts. Now it says in lowest terms, so we have to reduce it. So we can look at 3, 6, and 3, and we know that 3 goes in a, well, 3 goes into all of them. So we can divide this by 3, divide that by 3, divide this one by 3, and then we get, what's 3 divided by 3? We get 1. So we get 1 square, I'll write SQ for short, to 2, okay, so to 2 triangles, I'll write 2T, to 1 heart, I'll write 1H. Now here it asks us something different. It says write a ratio that is equivalent to 2 to 5. Now some of you may be looking at this and saying, Mr. Melham, you can't reduce 2 to 5. Nothing goes into 2 and 5. But it's not asking us to reduce. It's just asking us to make something equivalent. Same rule as fractions. Whatever you multiply one number by, guess what you do to the other? That's right. So let's pick a number. We can multiply. Hey, let's pick 6. We can times it by 6. If you times the first term by 6, or the first number by 6, you multiply the second number by 6. And then you get 12 to 30. And this one, these two ratios are equivalent to one another. You can actually even write them like this. You can write 2 to 5 is equal to 12 to 3. These two are equivalent ratios. We can also multiply by a different number. We can have done this. We could have done, pick another number. How about 3? We could times by 3. And if you do that, you're going to get what? You're going to get 6 to 15. And this would be equivalent to that, which would be equivalent to that. You can write them all in a straight line. You can write all of them together. This is also equal to 6 to 15. Because we haven't changed the balance. The balance is the same. Whatever we multiplied one by, we multiplied the other one by. Now here it asks us to write a ratio equivalent to a 3-term one. We have 3 terms here. So let's go ahead and do that. Pick a number to multiply by. It could be any number. You could even divide. Okay, if you can find a number that divides. Now I know 3 divides into all of them, so I could divide by 3. So you could choose to do this. Divide them all by 3. And then you get 1 to 7 to 2. And these two would be equivalent. You can also choose a different number. You can multiply. You can multiply by 4. Multiply the second term by 4 and the third term. And then you would get what? You get 12. Multiply this, you get 84. Multiply the third one, you get 24. And these 3 ratios, all 3 of them are going to be equivalent to one another. Now, I just thought of a question that you could get. I don't have it written in the slide, so let's write this down together. Let's say I have a ratio 6 to 8, and I make it equal to another ratio with a blank, and then you can have, let's say, a 24 over here. And your job is to find out what that blank, that missing number is. Now, what you would do here is you would compare like terms. Now, look, the first term and the first term is not much we can do here. But if you look at the second term and match it with the second term, look what you get. You get times what? Times 3. So we multiplied this number by 3. We times it. We times that number here. We multiplied the 8 by 3 to get 24. So what did we multiply the 6 by? We had to have multiplied it by 3 as well. So our missing number would be 18. I could also write it in this form. I can write 3 over 7 equals blank over, let's say 28. And then I'm going to ask you the same thing. What's that missing number going to be? Well, you stop and you say, okay, what did I times the 7 by to make 28? Times by 4. So you times this. I'm not going to call it a numerator because it's technically not a numerator because it's a ratio, right? So this had to have been a 12. That's right. That's how you would do something like this. Let me give you a little bit more different one here. I'll give you one more. Let's say we had a blank here and an 18. And I put equals, and then I'm going to put a 4 here, and actually let me erase that 4. Let's say we had, let's put a 6 here, and a 4. Yeah, sure, let's go 4 to 6. So what did we do? Well, now look at the second term and match it with the second term. Okay, don't go 18 and match it up with the 4. No, you match the terms up. Like you look at that second number, you match it with the second number there. So always match up the similar numbers. So look, we have the second number here matches with the second number. Now, what did we do with the 6 to turn it into 18? We times it by 3. So what did we have to times the 4 by? Yeah, by 3. So we got 12. 12 to 18 is equivalent to 4 to 6. Now it asks us to reduce this. So we have 14 to 24. Let's reduce it. So what goes in? I'll do 2 goes in both. So we can divide by 2. So lowest terms, that's going to be 7 to 12. Now ask yourself, don't just stop. Ask yourself, can you divide these ones and shrink them down? And the answer is no. So we've got our final answer. How about a 3-term reduction? We want it in lowest terms. So what goes into 6, 27, and 15? Think. 3. So we have divide by 3, all of them divided by 3. So we're going to get 2 to 9 to 5.